Today we are going to find the integral of tan 4 of x with respect to x, and basically we are integrating tan of x raised to power 4 with respect to x. So in order to find this integral, we will break this fourth power into product of two squares. We will write it as tan square x into tan square x, and whenever we come across tan square x in integration, we try to write it in the form of secant square x. And why is that? Because we know that secant square x is the derivative of tan x, so we can easily integrate secant square x as compared to tan square x. We don't know the integral of tan square x, but when we write it in the form of secant square x, we know that secant square x is the derivative of tan x, so we write the integration of secant square x as tan x. So we will write this tan square x in the form of secant square x, and this is the identity: 1 plus tan square x is equal to secant square x. And we want to write tan square x in form of secant square x, so this one, when it will be shifted to the right side, the value of tan square x will be secant square x minus 1. So I'm writing this tan square x as it is, and writing this tan square x as secant square x minus 1. So this tan square x is multiplying with this secant square x minus 1. So this tan square x will be distributed. So tan square x will be multiplied by secant square x. Here is that term, minus this tan square x will be multiplied by 1, which will give us tan square x. And this whole thing is being integrated with respect to x. So we know that this is one term, tan square x into secant square x, because this is a product, and this is another term, tan square x, because there's a minus sign between these two, and minus or plus sign basically defines the number of terms. So these are two terms, and we will integrate these two terms separately. And we can do that because uh, the integral is a linear operator, and it can distribute itself on the terms separated by negative and positive, minus or plus sign. So we will integrate this separately and this separately. So the first term will be integration of tan square x secant square x with respect to x, minus from here, and integration of tan square x, this tan square x with respect to x. Now here we have a term, we are integrating the product of tan square x and secant square x, but we know that secant square x is the derivative of tan x, and this is what helps us in integrating this product. Because let me give you an example, that whenever we have an expression and it has a power, and its derivative is with it as written with it as a product, like we have x here and it is being squared, and the derivative of x is 1. So in this case, when we have a function and its derivative is also written beside it, and it has some power, we can find its integral by simply adding 1 to its power and divided by the s- power. So we can see that we have tan x here, and its derivative is all written beside it secant square x. The derivative of tan x is secant square x, and it is also being raised to a power of 2. So we can apply the same thing. So the integration of this function was, we add to the power x, it becomes 2 plus 1 x cube divided by the same power 3 plus the constant of integration. So in this case also, we have tan x raised to power 2 and its derivative written. So we will add 1 to the power of tan x and divided by 3. Or another way of looking at this is that when we integrate a function with respect to that same variable, we basically think that what is, you know, which function has this derivative, like which function has the derivative equal to x square. And we know that this function or this power can come as a derivative when we take derivative of some cubic function, because the coefficient comes in front and we subtract 1 from the power. And if suppose we take x cube as a function and we check what its derivative is, its derivative is 3x square. The power is 1 is subtracted from the power and the coefficient comes in front. So the derivative of x cube is 3x square, but we don't have 3x square here. We can't write that the integral of x square is x cube, because we can write that when we have 3x square here, but we have x square. So in order for us to write that that the integral of this is x cube, we have to divide by 3, so that 3 which is missing here, which should have been multiplied here, is being divided here, so they cancel out the effect. So that's why the derivative of this thing is x cube over 3 plus c. And we can see that if we take the derivative of this thing, the coefficient will be separate. It will be 1 by 3. And the derivative of x cube is 3x square. And 3 and 3 will be cancelled. And we will be left with x square. So the derivative of this will be tan cube x over 3 minus, we will write tan square x as secant square x minus 1, like before. We did that in first step or second step. And we will distribute the integral operator on these two terms. This will become tan cube x over 3 minus the integral of secant square x with respect to x and the integral of 1 with respect to x. And this minus sign will be distributed on these two terms. So tan cube x over 3 minus, we know that derivative of uh, which function has derivative equal to secant square x, that is tan. So the integral of secant square x will be tan minus which function has derivative equal to 1, that is x. So x is written here. So this negative sign will be distributed on these two terms, and we will have tan cube x over 3 minus tan x minus minus plus x plus c. This will be our final answer. The integral of tan x raised to power 4 is tan cube x over 3 minus tan x plus c.